Guys, this one's going out by request. Today, I want to talk about molar mass. This is important as we start talking about chemical reactions and stoichiometry. What is molar mass, you ask? Refer to my notes. I was having some technical issues this morning, but I found some compromises that are going to make my life a little bit easier. Okay, so molar mass is the mass of 1 mole of particles. Particle could be anything. It could be an egg. It could be an orange. It could be an atom or a molecule. It could be a bicycle. But that's a mole. The mass of 1 mole of particles. Well, what's a mole? Well, it used to have all these different definitions. Like if I gave you a mole of carbon, 12, that would be a mole of carbon. But now we have this thing Na, which is Avogadro's number. Avogadro was one of the early scientists trying to figure this stuff out. This is Avogadro's number. And in 2019, it was defined as 2.022140076 times 10 to the 23rd. Exactly. That number is exact, according to the NAST. And I will give you some links in the description, too, about some other stuff that deals with this. But anyways, if I gave you a mole of something, I would give you 6.022140076 times 10 to the 23rd particles, whatever it is. That's what a mole is. It's like a dozen. When you're making a cake or a bunch of cakes, you talk about eggs, you talk about dozens. But when we do chemical reactions, we're dealing with these things that are infinitesimally small, and there's lots of them when you do use even small amounts of these substances. So let me talk about some real-world examples that deal with chemistry. Perfectly drawn horizontal line, flawless. 1 mole of carbon. Let's just give you a mole of carbon. A mole of carbon contains 6.022. Now, instead of writing the whole entire thing out, so whatever, I'll just good approximation, times 20 to the 10 to the 23rd atoms of carbon. That would be a mole of carbon. Well, what's the molar mass, you ask? What is the molar mass? Well, let's look at a periodic table, and we look at carbon. Carbon's over here. Atomic number 6 neutrons, but different isotopes. And when you average out the weights, all the masses, the mass numbers of all the isotopes, you get an average of 12.011. And that's handy for this discussion because the molar mass of carbon is 12.011 grams per mole. So if you weighed out 12 grams of carbon, you would know that that's 1 mole of carbon, and in that pile, just about 12 small paper clips worth of carbon, you would have 6.02 to 14076 atoms of carbon, and that would be your mole. So that's the molar mass. There you go. Let me try this. I can't have my canvas size too large or it robs memory. Thing bogs down and you can't read my penmanship, which is already bad enough. Let's keep going. 1 mole. Let's talk about a different element. We'll talk about a mole of hydrogen. Hydrogen is a diatomic element. Brinkelhoff, it's the H in Brinkelhoff. So when we find free hydrogen, it binds up with itself. So if you had a mole of hydrogen, you would have 6.02 times 10 to the 23rd molecules of hydrogen. Don't forget now, there's 2 atoms of hydrogen in every molecule, right? So when you look at the periodic table now, I'm going to go hydrogen. Hydrogen's 1.008. 1.008. So I would say that the molar mass for hydrogen is 2 times 1.008 grams. See that? There are 6.02 times 10 to the 23rd molecules of hydrogen, but there are twice that many atoms of hydrogen. It'd be like 12.04 times 10 to the 23rd atoms of hydrogen. So the molar mass for hydrogen isn't 1.008, it is 2.016 grams per mole. How do you like that? I'm going to do one a little bit differently, and I'll kind of show you conceptually how this works out. We'll talk about a different substance. This substance is KC. What happened? I'm still drawing straight lines. KClO3. That's not an I. That's an L. KClO3. We're not talking about potassium, carbon, iodine, and oxygen. We're talking about potassium, chlorine, and oxygen. All right, so if I gave you 1 mole of this substance, there would be Avogadro's number. Can I just write this, Na, so I don't have to write out the whole entire thing every time? Molecules of KClO3, potassium chlorate. So how many, let's break it down. Let's break it down. There are Na potassium atoms. Right. There are Avogadro's number worth of chlorine atoms. Yeah. And there are 3 times Avogadro's number worth of oxygens. I'm slopping this thing all up. Na worth of oxygens. All right. Well, if you do the math on this, periodic table coming in handy. Let's look at potassium. Potassium's over here. It's an alkali metal. 39.1, we'll call it. 39.1 grams of potassium. And I would look at chlorine, and I can just do this from memory. It's 35.5 grams of chlorine. All right. But I'll look at the periodic table. It's 3 times 16. That is the molar mass for oxygen, for 1 mole of oxygen atoms. But we have 3 moles of oxygen atoms. Yeah. And then, if you add these bad boys up, the molar mass of KClO3 is 122.6 grams per mole. How's that? I haven't had a backup for 331 days. What am I supposed to do? A long time. Coming up on my 1-year anniversary. Oops. Let's try another one. Last but not least, I'm going to cruise through this even simpler, leaving out some details. Let's just work this out. Look at the molar mass of H2SO4. What is the molar mass? Well, hydrogens, those are my elements. Sulfur, oxygen. I break down my molecule, my sulfuric acid. I've got 2 hydrogens, I've got 1 sulfur, and I've got 4 oxygens. It's 2 times 1 gram, roughly, for hydrogen. It's 1 times 32 grams, roughly, for sulfur. And it's 4 times 16 grams for oxygen. And if you add these guys up, you get 98 grams per mole. That's the molar mass of sulfuric acid. It's about 100 milliliters, roughly. And I would know that there are Avogadro's number, 6.022, molecules of sulfuric acid in that 100 milliliters. Now, just to give you a sense of what a mole is, I did a little bit of math. 1 mole, oops, because is I like to 1 mole of oranges. If I gave you a mole of oranges, the molar mass would be 3.01 times 10 to the 26th grams per mole, which is approximately 5% of the mass of the Earth. 5% the mass of the Earth. Well, that's why we talk about a dozen oranges and not a mole of oranges. Anyways, I hope that helped you guys out. Make sure you slap like and send me questions. You guys got any questions about anything? Hook me up. Take it easy.